So tonight we have Tim McDonald to present on the viability of industrialized deep energy exterior retrofits. And we're very pleased that he could come tonight on relatively short notice. He is a registered architect and certified passive house consultant, and a builder and founding principal of Onion Flats. That is an award-winning development, design, build collective centered in Philadelphia and Boston. So we're going to hear from him tonight about some projects that he's working on in Massachusetts that I personally find incredibly exciting, and I hope you all do too. Thank you, Tim.
All right. Well, thanks for the introduction, Adele, and pleasure to meet you all. I'm in Manchester by the Sea. My wife grew up here, and unfortunately her mother passed away a couple of years ago, and we moved up here to put our kids through a great school system here, and we've been enjoying the North Shore ever since, and we've got a lot of really interesting projects that are going on that I've only got about a half an hour, so I want to just show you a couple of them. So I'm an architect, as Adele mentioned, but I'm also a developer, a builder, and a passive house freak, I guess one would say. Why? Because I believe that, as you all do, given the nature of this organization that you're a part of, I believe that buildings are responsible for almost half of all greenhouse gas emissions. And if we think we're going to address climate change, we're not going to do it unless we do it with buildings. And specifically buildings in urban environments, because that's where populations are continually growing. But as a developer, architect, and builder since 1997, we decided to focus primarily on building net zero energy, carbon neutral buildings, and those are new construction, large scale, small scale, medium scale, historic buildings, towers, lots of different typologies, but we don't do anything unless our clients are interested in designing buildings that are carbon and net zero neutral. And the reason why I say that is because would we accept buildings that fall down as a baseline? No, right? Because we'd kill people, and that's totally irresponsible. Well, how can any architect design a building that contributes to greenhouse gas emissions when we have the technology to solve it and to eliminate it? And so just as an introduction, that's what guides us as our kind of main ethos. It's about building buildings that do not harm but support the environment. And I'm not going to talk about the work that we've done for the past 25 years. I'm talking about the work that we're in the middle of right now. And 2 years ago, we were approached by Rocky Mountain Institute to take on their Realize program. You guys can jot this down if you want. RMI, which is Rocky Mountain Institute, started a program called Realize, which is based on a Dutch program called Energy Sprong, which is about getting existing buildings to be designed to a net zero carbon neutral future. Because it's one thing to design new construction that way, but we've got millions of buildings that consume most of the energy in our world that need to be retrofitted to this new standard. And so Rocky Mountain Institute, as well as many other organizations, recognize this, and so they started out by saying, let's come up with a strategy that is replicable and hopefully done in a way that can be replicated through a panelized solution in the same way that Energy Sprong has been doing for the past 30 years. Long story short about Energy Sprong is the Dutch government said, we've got millions of units of affordable housing, of social housing that need to be retrofitted. They were built in the 50s and 60s, but we can't move people out of their units because it's too expensive to do so. So can we come up with a solution? Can the industry come up with a solution which is panelized, industrialized, so that you essentially design this envelope that has mechanical systems, high performance insulation and air tightness built into the envelope and can be installed while people are living in their buildings. And so that's the goal. That was the goal of the Energy Sprong initiative. That's the goal of the Realize initiative. And so over the past couple of years, we've started to build this pipeline of developers that are interested in doing this. And this is the first one, Alston Brighton CDC in Alston Brighton, Boston, neighborhood of Boston. And they own several projects in the area, two of which are ready for retrofit. And the first is called Hanno Homes. It's a 20-unit project and 10 duplexes. So just pay attention to the different typologies of building here. Got a wide variety of typologies of building. So there's no one solution that can work for every single building, as you'll see. But at least some of the ideas can be replicated. And so the second project is a 50-unit, 9-building project called Brian J. Honan Apartments. Okay, so the first one is Hanno Homes. As I said, 23,000 square feet. It's a series of row houses. And I got to say, as one of the first projects we're taking on, it's a really complicated project because it's got all of these ins and outs. It's got bay windows. It's got lots of different details. It's right up against the property line. There are, electric lines and telephone poles in the way. And so the promise or the thought of like a panelized solution, an industrialized solution, just made no sense here. And yet it still needs to be retrofitted. And so what's the approach to retrofitting the building? This is just an example of how we intend to kind of fill the roof as much as possible with solar. But in general, it's a 2-story building. There's 1 unit per floor. This is one duplex right here. This is the second floor of that, and this is the basement of that. And the basement is wide open. It's kind of a mechanical space. And notice the yellow wrap. That wrap, what we're effectively doing is wrapping the building in a nice warm coat. And part of that coat is our triple pane windows that get where we're replacing the single or double pane windows that are there. But in the basement is a mechanical space because it's kind of half underground and half above ground. And so it's a perfect place for mechanical systems. But one of the main questions was, how do we renovate these buildings without people moving out of them? And simultaneously, we're conscious not just of operational energy, which is what it's called. There's operational carbon, and then there's embodied carbon. Operational carbon is about how much it takes to heat and cool a building. Embodied carbon is about the carbon that is involved in the making of the materials themselves. So low embodied carbon materials is what we're always looking for. Timber HP is a new company in Maine that has just opened, and they're developing the first wood fiber insulation, both in batt form, batt insulation, as well as blown in insulation, as well as panel insulation, and we're using their panels on the outside. We're essentially wrapping the building in this wood fiber zone. And you can see some of the detailing here. Now, this is the existing building. So this is a wood frame building. These are the existing, this was built in 1900, by the way. And so the first thing we're going to do is put a new air barrier on the outside of it. We're going to strip the exterior and we're going to put a new air barrier on the outside of it. And then these windows are going to be built in a factory in the buck. This is called a buck, a frame around it, so that we can take the window and literally attach it to the wall, while the existing, see this dotted line, that's an existing window that stays in place. And so people are living in there. We attach this window to the wall, and then we fill it out all around with insulation, and then we put new exterior materials on. And then in one day we come in, while people are there, we take out the old window and we put in the new window and we seam it back in. So in general, there are tons of details you can imagine. There are decks that are tied into this. There are all kinds of complicated details, but I just wanted to give you a kind of basic idea of how this would work. And then secondly, how do the mechanical systems work? How do we bring heating and cooling and ventilation into these units without them moving out? Well, we do it from the outside. And here's an example of how that would happen. This is in the way. I can't see this. Yeah, so the red is an exhaust duct. The blue is a supply duct. So we're supplying fresh air, heating and cooling in between the old and the new facade. I'll show you a couple of details about how that works in a minute. But here's another example of that. And you know, as a reference, just keep this in mind. This is about a $4 million project for 20 units, which translates into about $200,000 a unit. That's expensive, as you'll see in a minute. But I want you to keep in mind what new construction would be at this point, because this is about $153 a square foot. New construction would be more than twice that. And so while it's important to keep in mind that this $200,000 is expensive, the whole point of the Realize program is to develop strategies that compress costs over time, especially if we have a large pipeline of projects that are done. There's the ability of cost compression that we're really working towards, and you'll see how that happens in the next couple of projects. But okay, and then right around the corner, literally on the same block as Hanno, is the Brian J. Honan project, which is a 50-unit project in 9 separate buildings, about 71,000 square feet. Here's how that lays out. They're all very different. I thought the first project was complicated. This is twice as complicated because it's got all kinds of filigree on the outside. It is one of the most difficult things I could imagine taking on, but we're taking it on because it needs to be taken on. And the good news about each one of these types of projects is that we get to see what it means to take on various types of buildings, and we'll find the common denominator between them. But in this initial stage of trying to figure it out, the idea is to kind of simplify these buildings, simplify the detailing of the buildings, cut off a lot of these kind of overhangs. See these dotted lines here? This is about chopping back some of the detailing around the building so that we can make this very clean. Look at this yellow coat of insulation. Doesn't it even feel warm? Just wrapping nicely around the building. And I'm not kidding when I say, like, it's critical that the red dotted line and the yellow is continuous, because it needs to be a continuous insulation and continuous air barrier all the way around. And then afterwards, simplifying some of the more complicated details that we're going to build back in. Okay, so that's just an intro. And by the way, those two projects are going to be built window by window, piece of insulation by piece. In other words, site built. It's a site built approach. It's not what Realize was really after. Realize is after a panelized, industrialized approach that can be replicated over time. Well, that's what gets us to this project. There's an organization called POA, Preservation of Affordable Housing. They own thousands of units in 17 states, many of which are in and around the Boston area. They bought these 4 buildings several years ago, all built, designed by the same architect, built by the same builder at the exact same time, in Salem and Beverly and Danvers and Peabody. We're taking on the Salem Fairweather project first. And the important thing about that is right next door, literally right here, to the Salem Fairweather project is a project called Salem Heights, also owned by POA. And over the past several years, they did a deep energy retrofit on this 281 unit project. Now, they didn't do what we're doing. They took it on in the way that they thought was the most appropriate at the time. And specifically, all of the brick in this project, everything you see, had to be taken off because all of the tiebacks had rotted away. Frankly, the facade was ready to fall off. And so, part of the idea of these new buildings that we're going to retrofit is that the brick is intact and we're putting this kind of coat on the outside. Same thing here, but they had to spend a lot of money on tearing off the brick, getting down to the structure. You can see the steel structure with metal studs here. And then this is the new facade that's going over that. But it was done on a piece by piece basis, one of these panels at a time. This is the existing structure, and they put this thick insulated envelope on the outside. And they wanted to attach it to the brick, but as I said, they had to take the brick off, so they attached it back to the existing structure. And this is what it was looking like in process. And again, I want to reiterate, every window was replaced one at a time. The tenants had to be moved out of the building. That's what that $1 million relocation fee means, which is insane. It was built for $160,000 a unit, much better than the last project, but even so, too expensive if we want to really grow this. The other thing that they did, which we're trying to avoid, is they chose a mechanical system that needed a closet on the inside, that needed a lot of interior work. And so what we said was we want to design a project where we can do all the mechanical systems as much as possible from the outside, because this is one of the main reasons why they had to relocate people. And so POA asked us to not just, come up with a plan for this building, but to come up with a plan for 4 buildings. And frankly, to figure out what is the best panelized strategy. And when I say panelized, I mean an industrialized panel, which has windows and doors built into it, that's built in a factory, that then you come out and you essentially attach on the building itself. So we actually did research on 7 panelized manufacturers in order to get to the one that made the most sense for this project. We also did research on 3 or 4 different mechanical systems that could make sense in order to find the right, most cost-effective one. So, and this is essentially what we're doing. We've got this red brick building, and we're putting these panels these insulated panels with triple pane windows built into them on the outside. Here are all of the panelized manufacturers that we did research on, and these are images from the panelized manufacturer that we're working with, which is Facade X and Metaleve. And as you can see, it's a metal stud frame with this thick insulation on the outside and windows and doors built into the panel itself. And this is the existing wall of the building. This is the new panel that gets. This is a metal stud wall right here, and this is that rigid insulation on the outside. But this is an all-important 6-inch airspace that allows us to run our mechanical systems in between the new and the old. And I'll show you a little bit more about how that works. These are mostly studios, like 300 square foot studios and 1-bedroom apartments. They've got a lot of existing mechanical chases in place that we're going to reuse. And we chose this centralized ventilation, heating, and cooling system, which you can ask me about. I'm not going to go into it in detail, but it's a VRF with heat recovery and decoupled with an energy recovery ventilator, ventilation for each unit. And it was the most inexpensive approach to doing it. So this is how we did. And this visually, this is what it looks like. Now, notice this is the existing building. All of this stuff you see on the roof right now is mostly cell tower equipment, which was not fun, I gotta say, to work around, because we've got to add more mechanical equipment to that roof. And I just want you to pay attention here. These blue lines are the supply ventilation ducts that come from the roof and slide in between the new and the old facade, and then go and give fresh air into each apartment. And this is how it looks on the roof. We're going to build this kind of parapet around there that encapsulates these supply ducts that run around the perimeter of the building. And then these yellow ducts are the exhaust ducts, because you need balanced ventilation, exhaust and supply. You have to have the exact same amount of air that you're taking out as you're putting in. And those we're reusing the existing exhaust shafts that are in the building. And then lastly, that's just ventilation. That's just bringing in fresh, filtered air 24/7. The air inside these buildings is going to be the best indoor air quality possible because of that balanced ventilation. But this last one is for heating and cooling. We have these condensers and what's called a VRF system that provides heating and cooling. By the way, these units don't have, well, no, that's not true. They have air conditioning, but they have these through-wall air conditioners. Those are all going away. And so it's all going to be this centralized strategy. We did an embodied carbon analysis on this as well, because they're metal panels, they're metal studs, and steel is a high embodied carbon material. But in the end, because it's a retrofit, if we were, just take a look, 80% energy savings, which is we're actually saving more than 80%. So the payback in embodied carbon, in other words, doing this, we'll pay back whatever embodied carbon is in that new facade and materials in 1.5 years, 1.25 years, which is insane. Now, if this was a new building, that would be 10 times that. And so what am I saying? I'm saying from an embodied carbon perspective, it makes sense to retrofit buildings. And from a operational carbon perspective, it makes sense to retrofit buildings. And most importantly, from a cost perspective, it makes sense to retrofit these buildings. In this case, because we've got all that stuff on the roof, we don't have a lot of room for solar, but the little bit we have, we're including 23 kW. And so how does that all translate? it translates as a baseline EUI. If you guys don't know what EUI means, it's energy use intensity, which is essentially miles per gallon for your building, 165 kBTUs per square foot per year. That's like the equivalent of, I don't know, 10 miles to the gallon, 5 miles to the gallon. It's horrible, right? And so what is our EUI after this retrofit? 87% better, or $128,000 in savings per year. Who wouldn't do this? And so then the real question was, one of the real questions was, this was built for $160,000 a unit, $1 million in relocation fees, $45 million budget. We were able to get this to work for $121,000 a unit, so 24% cheaper than the site build approach, because the intention here was, if we can demonstrate that building this high performance envelope in a panelized way, being built in half the time, can it be cheaper, especially over time? Can we get cost compression over time? And the answer is yes, at least with this first project, and it's only going to get better. So that's what we hope. And so last thing I'm going to leave you with, because I know we wanted a lot of discussion, is I'm going to be giving a much more involved discussion around these projects, and specifically the financing associated with these projects at this Passive House Symposium on December 5th. So if you guys want to write that down and check it out, it's not just us, but there's a lot of really great stuff that's going to be discussed, like about all the incentives that are out there for building to a high performance standard. Anyway, so that's about it. Thank you.
Thank you, Tim.
Yeah.
That was a whirlwind tour.
Well, 30 minutes is 30 minutes.
That's right. I'm going to ask one question and then turn it over to others to ask questions. You mentioned that there would be balanced ventilation, ERV, but you also mentioned that it was going to be filtered air. Now, is there such a thing as an ERV that has filters?
Oh, an ERV isn't an ERV unless it has filters.
Okay.
Absolutely.
Okay.
In fact, triple filters.
Triple filters. And what kind of filters are they? Are they like HEPA filters, or are they less than HEPA?
Yeah, so it depends on the equipment, but for instance, one of the units we're working with, it's got 3 filters. One is a HEPA 15 filter in the middle, and then 2 thinner filters on the outside. And the thinner filters, the HEPA filters are really expensive to replace, and so you replace them maybe once a year, but the thinner filters really do the heavy lifting. You replace them about 4 times a year.
Okay. Thank you.
Mm-hmm.
Other
questions? Therese.
I have a question. What was the response to the POA, from POA, I guess? Were they pleased with this result, and will you be doing the rest of those buildings?
Yeah, I mean, so the interesting thing about POA is the head of the design and construction of POA is a woman by the name of Julie Klump. And she just believes 100% in Passive House. And she believes that this is where her company needs to go. So she's been doing this for years. The big question was, to your question, the big question was, can we do it more cost effectively in a factory, in a panelized solution? And she was ecstatic when we got the preliminary budgets back and then followed up by even more recent budgets that, yes, in fact, it is cheaper, and it's going to get even more cheaper depending on the kind of pipeline and the scale of work. So yeah, she's ecstatic.
Eric,
Well, this is amazing. Thank you. It's kind of got my ears pinned back. I noticed the Honan apartments look relatively new to me. Maybe not.
Oh, yes.
But how does a building get evaluated or chosen as a candidate? I suppose you could say retrofitness. Sorry. Particularly where there might be insect or water damage, or I've dealt with mold before in buildings within the existing framework. I would assume that you would not consider that, or maybe just replace the wall with the panel or something. I don't know.
Well, look, the simple answer, Eric, is that every single building out there is a candidate. Okay, just let's get that clear. Nobody, this isn't for the lucky few. These first projects are simply the ones that developers who see two things. One, the incentives that are there in Massachusetts to do this. And I should give a presentation just on the incentives. Then again, you should go to the Passive House Symposium to actually get that information. The incentives at the state level, at the federal level, and at the municipal level are insane. They're insane. Massachusetts is the best in the country, the best state in the country to build net zero energy buildings. And frankly, if you're not doing net zero energy buildings, you're really missing out, because the incentives pay for anything associated with passive house, high performance buildings. It just simply pays that. So that's number one. Number two, I did not want to start out with these two projects, the Honan project and the Hanno project, because they're so complicated and they're expensive, but at the same time, it's what we got. And we started this 2 years ago, and I thought this is exactly what we should be doing, because there are so many buildings out there like this that people need to figure out how to retrofit. But to the point of they look like relatively new buildings, I'll just say this: they were built 18 years ago. And the fact that they are rotting from the inside just tells me, I mean, we're at least the 50s and 60s buildings were built in a much more kind of robust way. But these buildings, I think we're going to be looking at these kinds of buildings from 10, 15 years ago that are just going to be rotting, because all we do is we just slap skins on the outside of buildings that don't have rigid insulation, don't have a rain screen, and water infiltration and mold and all of that is going to be rampant in the next in the next couple of decades. And we see that by this project, which 18 years ago was brand new and it's falling apart right now.
But there's no attempt to improve the damage or
Absolutely
remediate. Oh, so you do remediate?
Oh,
from the
my
inside.
God.
Or from the outside?
No, it's not so much. So if there is mold that needs to be cleaned up and removed, that's one thing. These buildings aren't filled with mold necessarily. It's more the exterior is falling apart. Okay. The trim is falling apart. The flashing wasn't done properly. It's all that stuff. But whatever damage is done on the inside, certainly that needs to be addressed. But the fact that we're building this high performance envelope on the outside of the building means we're eradicating any possible future infiltration of moisture.
Are
Thank
you, are you satisfied, Eric? Okay.
Yeah,
You have,
thank you.
okay. Then we're going to move on to Bob.
Hey, so I'm wondering how the costs compare to what's being done in Europe.
Uh,
Is that summarizable?
yeah, I don't know. I don't have that information, Bob. It's a good question. But at the same time, I got to say, like, I would have different numbers from New York City than from here. So I'm not sure how relevant those numbers are, but I think what would be relevant, and I should actually do this, is to look at this work with Energy Sprung started about 30 years ago. It would be really fascinating to see what the costs were in the beginning versus what they are now, because I know for a fact that they have radically come down. The question is by how much? I think that information is more relevant than comparing their costs now to our costs.
Yay.
Oh, thank you.
Yeah.
Yeah, I'm so impressed with this. I mean, having lived in an 1890s home and having seen Soviet buildings across the coldest part of the world, every building needs this. So fantastic. I've been kind of trying to imagine how this would ever get done. So thanks for the imagination. I have a quick question though. For those of us, and I bet that's everyone on the call, who are activist oriented, like what can we do to help move this forward? What would you say are the key obstacles that those who are policy and action oriented could help with? Because I've heard you talk about funding, somewhat optimistically, building codes, panel manufacturing capacity, also maybe indirectly education of people. But what would really, open this up?
None of the things you mentioned.
Okay.
The only thing that is stopping any of this from happening is fear. Fear. It's fear with building owners. It's fear of the unknown. It's fear of cost. It's fear. It's doing something radical in people's minds. People don't like radical. I eat radical for lunch, but I mean, like, but it's literally that. Like when it comes to the political support, we've got it. When it comes to the technical support, we know how to do this. We know. I'll give you guys another presentation another day where I tell you about the project we took on in 2014, where we went to affordable housing agencies and we said, build to the Passive House standard. You can build it. You can build buildings that use 75% less energy than a typical building, and it doesn't have to cost more money. They're like, what are you, crazy? And I'll show you all the data of years and years of data that demonstrate that exactly happened. So we've got the technical knowledge. We've got the political support. In Massachusetts, at least, we've got the funding. We don't have it, the rest of it. We're not like Holland. We're not a socialist country. We don't have a government that we believe needs to do this kind of infrastructure work. So it's a struggle financially, no question about it. That is a huge issue, but not today in Massachusetts. Today in Massachusetts, if your organization wants to make a difference in climate change with buildings, you got to do it in the next couple of years, because the funding's going to go away. And the intention of the reason why we're so excited about the IRA funding and the Mass CEC funding and the Mass SAVE funding and the HUD GRRP funding, all of that funding that's out there, which translates into millions of dollars per project, the intention of which, of course, is to get as many buildings as possible to do this so that costs come down, so that we don't need these incentives. Right? So that's a long way of answering your question, but
it's great, but it's not, we can't just jump to scale overnight.
we can't.
We may have the technical knowledge, but how many builders know how to do this now? And how many factories can build those panels, and how many units do we have to retrofit in Massachusetts? So that was really what I was trying to get at.
So in Pennsylvania, when we proposed that people build to the Passive House standard, the Pennsylvania Housing Finance Agency funded, in 1 year, they funded 7 multifamily projects to be built to the Passive House standard. None of the builders had done a Passive House project before. None of the architects had done a Passive House project before. They were in the exact same place as what you're saying right now. And guess what happened? They figured it out. You know why they figured it out? Because they had to. They had to. They went in, they said, we're going to build this Passive House project for this amount of money. And PHFA said, you know, we're not giving you any more money to do this. You just have to do it. They said, yeah, we're going to do it. And they did it. So look, I'm not trying to minimize the training that needs to happen, but should I give a presentation on how much time we have left before the 1.5 degrees centigrade issue? I mean, time is not our friend right now. So we've got the technical knowledge. We'll transfer it project by project.
Here, here. Felicia.
So I'm one of the less techie people on the call. And it sounds to me like education needs to happen. That's part of it. Another part is for people to know where the funding is at. I feel like there's a lot of confusion about where's the funding here yet? Where is it? Like that kind of thing. And that might happen in your next presentation. But like for the $200,000 per unit, who ended up paying for that? Did the owners pay for it? Was it rented out? Did the renters pay it over time? Did the state kick in? Like who paid?
Wide range. And the thing about, if you don't know how affordable housing gets funded, it's not easy. It's not easy to communicate. But a simple way of answering your question is, I mean, it's funded by all of us, because affordable housing is an oxymoron. It's not affordable to build affordable housing. To build buildings that people live in that make 50% area median of income are not affordable. Right. So there's nothing about affordable housing that works unless it's subsidized one way or another.
Right. So this was
in Canada, in Europe, it's the exact same thing. In the States, it's a different, tax credits and all of that. But in the end, we all pay for it, just like we pay for our roads.
But it was subsidized in some way, that 200,000.
100%, almost 100%.
All right, so that was one question. And the other one is, I know that the big buildings really need to be done first, but especially around here, there are a lot of individual houses. And is there a way we can inform, like I'm a homeowner and I'm kind of confused about how to get my house as insulated as possible without spending tons and tons and tons of money. So I'm trying to figure out how I can talk to people about that and where I could turn for more information.
Mass CEC.
Okay.
If you guys don't know Mass CEC, Mass CEC, unbelievable woman by the name of Beverly Craig, who, by the way, is going to start out this symposium. She knows more about all incentives in Massachusetts than anybody out there. So,
yeah, Mass Save hasn't done so well by me, but maybe.
Okay.
You're not alone.
And
Yes, hello. My question may have already been answered in the chat. On the HVAC systems, is it primarily heat pump in terms of fuel? And does your approach require any fossil fuel or other backup to?
Thank you, Ken, because I didn't even make that point, because these days I kind of forget. All electric buildings, all the way, all the time, nothing else. We haven't put gas in a building in 20 years. Never will again. No need. It's more expensive to do so. It's less expensive to do all electric buildings. So yes, heat pump technology for everything, for heating, cooling, hot water, everything you can imagine.
And that even works at on a large scale, central air approach on those.
Absolutely.
Thank you.
By the way,
Okay.
does anybody know the wonder of heat pumps? Does
The-
anybody not know the wonder of heat pumps? Can I just tell you if you don't? Okay, just imagine this. It's magic. 1 unit of energy.
Physics.
Like you've got baseboard heat in your house, electric baseboard heat, let's say. 1 unit of energy goes into that baseboard heat. You get 1 unit of heat out of it. That's brilliant. There's like no waste, right? 1 unit goes in, 1 unit of heat comes out. Do you know what a heat pump is? You put a unit of energy into it, you get 3 to 5 units of heat out of it. What? Why aren't we teaching our kids about this? Anyway, I get
teach
excited.
physics. I teach them.
Yeah, I get excited when somebody mentions the word heat pump. So
Pam, you have a question. But you're muted. Thank-
My question is actually for Carol Collins, if she's still on.
She's not on. She had to get off, but
Well, what I know was we have a building that is using passive German methodology, which is the old Wilson's department store building, and it's being converted to multiple affordable housing units, condoized. And I wondered if this is appropriate for that building.
absolutely. It's appropriate for every single building. You know what we're doing in New Bedford, Massachusetts right now? We're doing a retrofit and new addition to a YMCA. It's going to be the first YMCA in the country that is a net zero energy building that's Passive House certified, and it's got 2 pools. Net zero energy, people. Net zero. 2 pools that are at whatever, 70 degrees all the time. How do you do that? I mean, we can do this. And we just need to do more of it as quickly as possible.
Here, here. Eric.
I'm been working on converting a church from gas to heat pumps. And we're installing a monitoring system to figure out really whether, how close to net. So I'm curious about that, if maybe the panels actually have a built-in way of doing that. But and secondly, what's your builder education model? It seems like there are a lot of builders who would like to know this or already know some of it, but actually doing it in the field. So do you have builders observing the existing projects and then going through the details of it? How do you do that? Because it's got to go to a lot of that's where it happens. Yeah.
So as I said earlier, my experience over 27 years of building, again, I've been a builder, developer, architect, is the absolute best training is on a project. However, we take risks that other people don't necessarily want to take. So you got to get training. So FIAS, Passive House Institute US, FIAS.org. If you don't know FIAS, please look it up. They have tradesman training. PHI, which is the International Passive House Institute, they have tradesman training. I got my tradesman training certificate through PHI. So, but FIAS is putting out a lot of tradesman training, and that's essentially contractors come and do. They have various grades of training. So yeah, it's built in. It's there. We require everybody on our team, the GC, the main people on the GC team, to take that tradesman training while we're taking the class, not before, but while we're doing it, so that the language, the kind of narrative is understood between all of us. Yeah. Yeah, was that enough? By the way,
One
I
of
didn't
the-
see who asked that.
It was Eric. Oh,
Oh,
and
okay, Eric.
Darcy has a question.
Yeah, I have a couple questions. One is, is wood insulation preferable to cellulose, or are they the same?
They're pretty much the same. I mean, cellulose is a wood-based product, but it comes from newspapers and whatever. It was processed once already. But yeah, it's essentially the same. And this, if you don't know about Timber HP, just Google them. It is a beautiful story. And the story is this, that Maine was filled with paper mills for hundreds of years, right? They all closed in the past 100 years, all of them. I think all of them. But these guys and their architects and their passive house people, like it's all about passive house. They realized that wood fiber insulation is the absolute best insulation out there for smaller scale buildings. And we can't, and it's expensive to get it from Europe. They've been making it in Europe for generations. So they bought an old paper mill that was abandoned, brought this whole new industry to Maine. Maine, what is and the best thing about wood fiber insulation, it's not the wood of the trees, it's all the cutoffs, it's all the scrap that you make this insulation out of it. And it's better and the same cost as any other insulation that's out there.
Cool,
It's
okay.
awesome.
I also wanted to know, I might have missed this, but what is the actual outer layer of the exterior made out of?
Anything you want.
Oh,
Could be
So
anything.
you
Could be
you add
cedar.
siding over your
Yeah.
panel.
Yeah.
Uh-huh.
Metal panel. We're using metal panel. We're using hardy board. We're using cedar. It doesn't matter. Brick.
Mhm. And my
Yeah.
last question is, around here in Amherst, we have a ton of, building apartments, large, tall dorms, that are dorm/apartment complexes. And they're all, owned by private landlords. So they don't fall into that category of owners that really are just passionately interested
You're
in
right.
climate action. So do you have ideas about
Yeah.
how
It's a
to
great. Yeah.
go after them?
So you ask a question that is a little thicker than that for me. And the reason why is because people ask me this all the time. It's like, why aren't you focusing on market rate developers? Like, why aren't you focusing on people that, can afford this stuff? Ironically, the developers who build market rate housing are the cheapest developers out there. They don't want to put any more into the affordable. Nobody does, but the affordable housing developers are run by the rules of the Housing Finance Agency. And so they've got to do certain things a certain way. Affordable housing developers, it's like you can do whatever you want. So my answer to you is this, that again, in Massachusetts, if a market rate developer would actually look at the incentives that are out there to build to this standard, they will discover that. I'll give you one example. We're doing this YMCA, right? And we're dealing with a board, and the board is filled with lots of different people, lots of different personalities, lots of different political alignments, right? And they're challenging everything. What are all these bells and whistles, all this passive house bells and whistles stuff? We said, okay, let's give you a spreadsheet. Here are the bells and whistles associated with Passive House. Mass CEC did an analysis of all the affordable housing projects that have been built to the Passive House standard over the past couple of years. And they analyzed the costs and they compared them to code-built buildings. And the cost difference between the code-built affordable housing and the Passive House affordable housing, I think there were like 8 or 10 of them, was between 0 and 4.3% increase in cost over the code-built building for a building that uses 75% less energy. 0 to 4.5%. Do you know what a contingency is in a budget? It's between 5 and 10%. You could build a Passive House building with your contingency. Okay. So we showed that to them and we said, you know what? Let's say it's going to be 10% more, not 4.3% more or 0%. Let's say it's going to be 10% more. And it's a $25 million project. That's $2.5 million. And then the next slide I showed them were all the incentives for high performance building that were $2.6 million. So paid for. So there's no reason why a market rate developer can't build a Passive House unless they're just afraid and don't want to do it.
Oh, that's great to know. We just need to get the landlords together to.
The way I look at it, Darcy, is do a project. Like I spent too many years trying to get developers to do something. And then I just realized, just build one. Just build one and then build another one and then build another one and get one person and then build another one. And that's where we are in Massachusetts. And the pipeline that is being built for these retrofit projects right now and the money that is there for them to do this, it's unlike any other time in Massachusetts. And I think within 5 years, certainly within 10 years, code is going to require this. I mean, we have now accepted IECC 2021, which is the International Energy Code 2021. It's not even 2023. And that's as close to Passive House as you can get. And the next code adjustment is going to be Passive House. So we're only talking about a couple of years here before everybody is required to do this. So why not get everybody going now? You know, especially while the money is there.
Yes, and as I had mentioned, we have a couple of very tall brick, ugly buildings, affordable in Northampton, that really need to be retrofitted in this way. So
the uglier, the better.
Yes. Eric, you have your hand up. And I think you are going to get the last question.
I'm sorry, I have so many questions. I'm excited about this. Thank you, you guys who brought Tim here, and thanks, Tim. You mentioned a CDC in Boston. Are there other CDCs involved? I've been in conversation with a CDC in Springfield on heat pump coaching and whatnot, and they already do internal audits, but I might want to ask if they might have some buildings that would qualify.
And like I said, Eric, they all qualify. Everyone qualifies. But what I would suggest is I'll connect you with folks at RMI, because they would be the first people, right? Because essentially what RMI is doing is they're kind of aggregating. They're trying to build demand, right? Both nationally as well as in Massachusetts. They have their tentacles out to multiple developers, and they're saying, if you've got buildings, bring them in, because they want to build a pipeline. Why? Because the panelizers, they don't want to do these one-off buildings, right? They want to know that I've got 5 years worth of this stuff in line, and then they'll invest. They'll invest in the infrastructure. They'll invest in so it's critical that we get a pipeline of buildings going for not just this one panelizer that we're working with, but we need multiple people, multiple organizations that do this. So yeah, connect them with me and I'll connect them with RMI.
Okay, thank you.
Thank you so much, Tim. This is
My pleasure.
so exciting to me.
I know, me
Yeah.
too. Me too. Keeps me going.
And thank you very much for offering to give future presentations to us.
Absolutely. Anytime you want.
Thank you.